This is a proof by contradiction question. Use proof by contradiction to show that if n squared is an even integer, then n is also an even integer. So because it's contradiction, we have to do an assumption statement to start with. So assume that there exists there exists a square number. There exists an n such that n squared is even, but n is odd. So remember, your assumption statement is a negation of the thing that you're trying to prove. And because this is a if n squared is even, then n is also even, then the negation statement is always if n squared is even, then n is odd. So it's the opposite of the second bit. So if n is odd, then we can say let n equal 2k plus 1. And so n squared would be 2k plus 1 squared. And if we expand that out, we get 4k squared plus 4k plus 1. And if we just take out a 2 from the first section, we can say that this is 2 times something plus 1. And then 2 times something, that makes this bit even. But then if we add 1, then this whole thing must be odd. And that's a contradiction, because at the start we said assume that there exists an n such that n squared is even, but n is odd. And we've shown that if n is odd, then n squared must be odd as well. So that's a contradiction of our first statement. Therefore, just put a conclusion statement in. Therefore n squared is if n squared is even, then n is also even. And then you'll find this is an example in the Year 2 Pure Book, page 2, example number 2. Okay, so the next question that we had to do was this one. So it said prove that root 2 is irrational. This is also an example in the textbook. I think it's example number 3 in the Year 2 Pure textbook. And this is it's really common proof, proving that a surd is irrational. So this is also done by contradiction. So assumption statement is that assume that root 2 is rational. And if you're assuming that root 2 is rational means that it can be written as a fraction. So if root 2 is rational, then we can say that root 2 is equal to a over b. And it's really important that at this stage we say that this is in its simplest form. Because this is, at the end of this is what we're going to contradict. So this is in its simplest form. Okay. And any fraction can be written in its simplest form, so that's fine. So how this starts, and as I said, it's quite a common question, and the proof method is pretty much the same all the time. So we'll square both sides, so we can say that 2 is equal to a squared over b squared. If we rearrange that, we can say that 2b squared is equal to a squared, and this implies, that's the symbol for this implies that a squared is even, because a squared is 2 times b squared. And in 7a, we showed that if a squared is even, then this implies that a is also even. Okay, so therefore let a equal 2k. Because it's even, we can write it as a multiple of 2. So now we've got 2b squared equals 2k all squared. Let's expand that. 2b squared equals 4k squared divided by 2, and so we get 2k squared like that. And so b squared is also even. This implies that b squared is even, and if b squared is even, that implies that b is also even. And if b is even, therefore let b equal to, pick a letter, and so I'm going to go with f. So 2f. Now, so b is equal to 2f and a is equal to 2k. Now remember that root 2 was a over b. So that means that a, which was 2k, and b, which was 2f. So root 2 is now equal to 2k over 2f. And we can cancel 2's. But that's a contradiction, because we said that a over b was in its simplest form. So there's our contradiction, not in its simplest form or something. In its simplest form. And therefore root 2 is irrational. And that's the end of that proof. In terms of mark allocation, I would have said assume that root 2 is irrational, and then writing this first statement here is an accuracy mark, a method mark for saying root 2 is and over here for squaring both sides and rearranging, and then to get a is equal to 2k, accuracy mark there, and then another method mark for subbing it back in and rearranging to show that b squared is even, and if b is even, then an accuracy mark for writing it as a multiple of 2, and finally a cancellation, a conclusion, and getting a final answer with a statement is another mark. So, and that's your 6 marks. Okay.